Thank you. Thank you. So today I'm going to talk about JSON Web Tokens. Any of you familiar with JSON Web Tokens? OK, just go get a beer and skip this session. For those of you who are not familiar or don't know everything about it, I will try to talk a bit about them, explain why they're useful or why I like them, and explain how you can use them. But first, let me get started by just introducing myself. My name is Sam Bellen. I'm from Belgium, and I'm a developer evangelist at Auth0. If you don't know Auth0, we're an identity as a service company, which basically means that we try to make it as easy as possible for everybody to integrate a secure authentication flow so you can focus on building your actual apps. I'm also a Google developer expert, and I organize a few meetups, one in Belgium and one in London, which is the identity and security meetup. So should you be in London, please join, the same in Belgium. And you can find me on the internet as Sam Bellen. Oh, I have a bunch of cat stickers, so if you want cat stickers later, come to me, show me your cat or other pet, and I'll give you some stickers. Because who doesn't like cat stickers, right? So this is what we're going to see today. We're going to have a look at traditional authentication, how it used to be handled and still is getting handled, and there's nothing wrong with this. But since single-page applications started to get popular, we ran into some problems, so we're going to look at those problems as well. I'm going to try to explain what a token is. We're going to look at token-based authentication, and then we're going to look a bit forward to the future of authentication. So traditional authentication, what I mean with this is authentication with web apps, mostly, which trigger a refresh every time you click a link, like server-rendered or server-generated pages like PHP, .NET, whatever you want. So imagine this. You have a user, goes to your website, your web app, and the web app just going to request the HTML page to the server is going to send that back. That's all simple. But what happens if that page is protected, like you have to log in first? The user is going to see a login form or a login page, going to enter his credentials, username, password usually, and send those credentials to the server. The server is then going to evaluate these credentials, and when it's OK, sends back that protected HTML page or whatever page. And the user is going to see this. But it's not only going to send back that page, it's also going to send back a session cookie most of the time. So we're going to store this cookie in the browser, and every time we want to access another protected page, we're going to send this session cookie, and the server is going to see, hey, this cookie has a session in it, I know this session, let's use it, and send back the protected page. Straightforward, right? Who's used an example like this, or a scenario like this? Most of you. OK. So traditional web apps versus single-page applications. The traditional architecture, like we've seen before, you have a page and a server, usually one-on-one. This can be multiple servers, but let's just assume that this is one server, which handles everything from generating the pages to all the logic, to authentication, to everything that you need to do on the back end. But a single-page architecture is usually a bit more complex. Like you have your single-page application running in the browser, but you cannot do that much logic in it because it has to be secure, and single-page applications run in the browser. It's all JavaScript. You cannot do sensitive things in there. So you have APIs. Maybe you have one API, or you have multiple APIs, like one for your authentication, for your accounts, for handling payments, whatever you want. But now we have a one-to-multiple relationship already. So not only that, you can have a multi-architecture, something like this, a mobile app, a web app, a desktop app, all connecting to the same API. But a mobile app and a desktop app usually doesn't use a cookie, right? Is there anybody who uses cookies with mobile apps? No, because you can't. It's something for the browser, it's something for the web. But we would like to have all these apps work in the same way with our API, want to authenticate them more or less in the same way with our API. So we want to step away from cookies. So what are some of the problems with traditional cookie-based approach? Cookies don't like CORS. Who likes CORS? Nobody? I thought so. Nobody likes CORS because if you run into a CORS problem, what you do is you go on Google, you type CORS problem, you get on Stack Overflow, and there's one answer which answers the whole word. So nobody likes it. And it can be a pain in the ass. So cookies don't like CORS. Cookies require state because these cookies are session cookies, and there's a session token in them, which you kind of have to save somewhere on the back end. And every time you send this cookie to your back end, it's going to validate if it's still a valid session. So you need to require state. And an API we should try to make APIs stateless. It's not that easy, but we should try to make it stateless. And with session cookies, that's not really possible. Cookies don't flow. If you have multiple APIs, multiple servers, these cookies get created by this one server, but they don't work with the other servers, so they don't flow from one server to the other, which can be a problem if you want to have a cookie generated by your authentication server. Also, if you want to use that one on your whatever data server or whatever you want to use it. So they don't flow. Something like this, API, and you want to get some user details from another service or server or whatever you want. So if the first API that somebody will be it issues a cookie, it will not work on the second API. So that's a problem. So what's the solution? Maybe it's token-based authentication. Maybe there might be other solutions. I'm going to talk about tokens and token-based authentication today. But first, what's a token? Who has used a token before? OK. That's good. So a token is a unique identifier representing something. A session ID, a user ID can also be a token. Usually it's a UUID, something that represents something in your backend that you can link it to. It's often an opaque string, like a UUID, but it can also be a SAML token or a JSON Web Token. Who has used JSON Web Tokens? Who likes to use JSON Web Tokens? There's a few people who don't like them. OK, I'll try to convince you otherwise. So let's have a look at a JSON Web Token. At Auth0, we use JSON Web Tokens as much as possible. Access tokens, ID tokens, we use them wherever we can, just because we like it and because it has some advantages. That being said, this is a JSON Web Token. And as you can see, it consists out of 3 parts. Who's ever realized that there's 3 parts in a JSON Web Token? Nice. Cool. So you have 3 parts. The first part being the header. And the header is basically just containing some metadata about your JSON Web Token. Something like it uses this algorithm to sign this token. It is a JSON Web Token. It's funny, but the JSON Web Token has the type JSON Web Token, identifying itself as a JSON Web Token. So the header contains some metadata you can use later on to use these JSON Web Tokens, the most important one being the algorithm used to sign the token. The middle part is the payload, and it can be a whole bunch of stuff inside of this payload. It can be something like this. The payload is just JSON, and everything that's valid JSON can be inside the payload of a JSON Web Token. You can put as many key value pairs in there as you want, but of course your JSON Web Token will grow in size. And if you send this with every request, it's going to be a pain in the ass, so try to keep it limited. And there's a few claims, a few different types of claims you can put in them. A claim is a key value pair, and the first one are reserved claims. These are claims that are mentioned in the JSON Web Token spec, like sub, which is subscriber or subject. I can't remember at the moment. Issuer, I issued this token. It expires at this timestamp, and stuff like this. It's issued at this timestamp. So this JSON Web Token payload contains some information we can use later on. One of the most important parts is there's an expiry date inside of this JSON Web Token, which could be useful. It can also be public claims like family name and given name and preferred username. And these are claims which are not really mentioned in the official spec, but they are. There's another list of them on iana.org. Let's see if I can open it. Yeah, it doesn't work. And my address bar is gone, so let's just ignore this for now. Good to know that there is a list with other claims which are not mentioned in the spec. This list is just meant for API interoperability, like if Facebook makes an API and Google makes an API and we make an API, you want to know how to ask for a family name or a given name on all of these APIs without thinking about, is this going to be family name? Is it going to be last name? Is it going to be first name? Is it going to be given name? So if you use these claims, like mentioned in the list which didn't work, you might have a better API interoperability. So that's the second type of claims you can put in your payload. The third one is private claims. And this can be anything you want, anything that is of relevance to you. If you want to put some data in that token that you think is necessary for your app to work properly, you can put it in here as long as it's valid JSON. One side note, don't put sensitive data in this, because this is publicly accessible by everybody who has access to your JSON Web Token. So keep it with data that is not really important or sensitive, but you can use it in your app anyway. And then the last part is the signature. And this is basically just going to prove that the JSON Web Token is valid, it's not been tampered with, you can trust it. It looks a bit like this. There's a bunch of algorithms you can use. If you use HMAC, it's the base64 of your header with a dot in between, and then the payload, the base64 of the payload, and then you add your secret, and you just run this, this function, and it gives you your signature. If you use other algorithms, you're going to use a private key and a public key, which is more secure, but this is easier to show. So you basically just run an encryption or a signing algorithm with your header and payload inside of it, and that's your signature. So JSON Web Tokens can be verified by this signature, your super secret key, which is usually a random string which you give only to the people or servers who need it, and you don't spread this around. If this is a key, private key, you give your public key to some other people so they can verify your signature with this public key. But by using your signature, you can verify that a JSON Web Token is valid and has not been tampered with, since the header and the payload are inside of this signing function. They have been encrypted, let's say, as well. So let's take a little example. We have our header, we base64 this, then our payload as well, and then we just run these two base64s through a signing algorithm, and you get the three parts of a JSON Web Token: header, payload, and signing algorithm. And if you then just put a dot in between the three parts, that's a JSON Web Token. If I would copy this here, and go to JSONWebToken.io. Has anybody ever used JSONWebToken.io? Nice. It's a really useful tool. It's made by us, just as a disclaimer. But it basically allows you to encode and decode JSON Web Tokens. So if I paste this in here, you can see the algorithm appear on the right, the payload, even though there's a space missing between my first and last name because I made a bug. Oops. And then you see that it's an invalid signature because my secret key is not your 256-bit secret. It's, I think, this. And if we then paste it again, no, maybe it's secret. Yeah, and you see that now my signature down there, it's verified because it uses my secret. Of course, don't use secret as your secret because it's a really bad secret. But by just taking these base64 of your header, your payload, and then signing them with some algorithm, you can create JSON Web Tokens, and you can see that the content is whatever I put in there earlier, except there's a space missing between my first and last name. So JSON Web Tokens are pretty cool. There's a lot of information in them, and they're not that hard. If you want to do it in JavaScript, it looks a bit like this. I'm not going to pay much attention to this. It's just taking the base64s and then encrypting them again, or signing them again. So we talked about HMAC, which is a symmetrical algorithm. There's also a bunch of asymmetrical algorithms which use a private and public key pair, like the ones listed below. You can use all of them. They're all valid in the JSON Web Token spec. Should you want to share keys, because these asynchronous, these algorithms here at the bottom, they use a public key and a private key. Should you want to share this public key with some other services, you could use something like a JSON Web Key, a JWK, which is basically a JSON representation of your public key, and it looks a bit like this. Of course, the values are a bit longer. But there's everything inside of that JSON Web Key that you can use to verify other JSON Web Tokens signed with this public key, or this private key, of which this public key is originated from. So that's a JSON Web Key. JSON Web Tokens, JSON Web Key. There's also JSON Web Signature, so I'm not going to talk about this. There's also JSON Web Encryption. So there's a lot of JSON Web stuff going on. And they're all nice specs, and they try to make it as easy as possible to use encryption and signing and stuff like this on the internet. JSON Web Tokens being one of the most useful at the moment, simply because you can just send them with every request, and they have data inside of them. So let's make a little comparison. Let's pretend that the header is the outside of my passport. I'm from Belgium. This is what's on the outside of a Belgian passport, saying it's a passport from Belgium in 4 different languages, because we're crazy. But basically, it's the same thing as the header of a JSON Web Token. It says what it is. It's a JSON Web Token signed with this algorithm. Your payload, same thing. The inside of your identity card or of your passport, my name, my surname, my nationality, the same thing can be inside of a payload of a JSON Web Token. When it expires, for instance, as well, I didn't put this in this example, but that's a nice thing to put inside as well. And the signature is somewhat comparable to like UV lights protection on these passports. So you could say that a JSON Web Token is more or less a passport. So let's see it in action. I have a very, very simple API which lets you request dog and cat pictures. Of course, and if you want to get a dog picture, it just gives them to you because dogs are friendly and they want to be with everybody. But if you want to ask a cat picture, you can guess. You need to be authorized because cats are a bit trickier. So now it says no authorization token was found because I didn't send a token. Now, if I send a token as a bearer token, it will say to me, hey, here's a cat picture, which is more or less like every opaque UUID or whatever token you've used before works. If you have a token and it's a valid token, you get what you want. But if, for example, you use an expired token, let me copy an expired token. I miscopied. I'm doing something wrong. Anyway, I'm not going to spend too much time on this. Maybe one more try. If I can find my mouse again. I saw it. Send. All right, so I just copied an expired token, which is a JSON Web Token with an expiry date, which is past this instance. So it already tells me this token is expired without having to go to a database, looking up this session token inside of this cookie or this token, and going to see if it's still valid in the database. The expiry date is already inside of your JSON Web Token, which is something very useful. The same thing for something that's been tampered with, like your signature doesn't match up anymore with the one you say it should be. Invalid signature. So if, in this instance, I took a token and I tried to change something in the payload, but my signature was not changed, so it just says this is an invalid signature, which means that somebody has tried to tamper with this token. So you can catch all of these things with these tokens without going to a backend and doing some lookups in databases or some logic, because it's all built into a JSON Web Token. And that, in my opinion, makes JSON Web Tokens very usable and very awesome. So, JSONWebToken.io, if you want to play around or want more information, it's a website that we've launched where you can create or debug web tokens. We don't store them on any server because some people think we do. We do not. It's all happening on the front end, on the client side. So go ahead and play around with JSON Web Tokens. But let's move on. Token-based authentication. We have our Our example from the beginning, we have a user who wants to go to a website and request a single page in this case, instead of a old school server-rendered or server-generated web page. But it's protected, so we're going to send some credentials to that web page through a login form, and then we send those credentials to our server. The server is going to check if these are valid credentials, but instead of sending a cookie back, it's going to send back an access token. And we're going to use this access token every time we're going to ask for protected data in the future. So instead of a cookie coming back, we get an access token, which could be in the form of a JSON Web Token. Doesn't have to be, it could be. And then we don't really want to save this permanently in the browser, because it can be stolen, so we save it in memory. And then every time we want to access a protected resource, we just send it along. It will prove that we are allowed to access this resource, and we get the stuff we need. So again, the user fills in the login form. We pass the data to the authentication endpoint or authentication authorization server. It validates this, and if it's valid, you get an access token back, and we send along this access token with every request in the future. Looks like this in JavaScript, very simple. The only thing you need to remember is that we send this here as an authorization server in the headers. Can just do this with any programming language. This is just JavaScript. Let's move on. Who's ever used OAuth? Who's ever used OpenID Connect? Far less than OAuth. And I think some of you might actually have used OpenID Connect without even realizing it, because OpenID Connect is just another layer on top of OAuth. OAuth specifies access tokens and refresh tokens and all of this. OpenID Connect uses all of this, uses the same framework, but adds an ID token on top of it, which is a token which contains some more information about the identity of the user that's been authorized or authenticated. Apart from that, it's exactly the same as OAuth. So let's look at a simple example. You have a single web page, a single page application, and instead of having one server, now we have an authorization server, accounts.samego.be, and then our just regular API. We request some, or we just pass along some credentials to this authorization server. If they're OK, we get back an access key, an access token. But we also get back an ID token and a refresh token, because access tokens usually are short-lived, so they expire very fast. And if you want to get another access token, you can use a refresh token. And the ID token contains some information about the user that just authorizes itself, so you don't have to go to a /user endpoint and ask all of this information, like its username or email address or profile picture. You get it from the moment it logs in. So that can be quite useful. If you use accounts@google.com, if you use Google, for example, to log into a server, they will usually send back an ID token as well. So you get back 3 tokens, and then you pass along this access token every time you want to access a protected resource. And then you get data back. The arrow is in the wrong direction. But this means, like I told you before, you don't want to save these tokens somewhere permanently, because if you put them in local storage or in a cookie, and you have some malicious code running on your website, they might be able to steal these tokens and use these tokens to pretend that they are user instead of the user itself. And you might say it's not that easy to steal tokens or something from cookies or local storage, whatever. But how many of you use NPM to download some packages for your single page applications? And how many of you actually looks inside of this code which you download from NPM, what's inside of it? I do not. Nobody. So you all read the whole code and all the child packages of every NPM module you download. Swedish people are really, really nice. Most people do not. So there could be some malicious code inside of these packages. You assume there's not, but if there's malicious code, they could just access your cookies or your local storage and send your access tokens to some malicious server, so they could be stolen. That's why you should try to avoid to save them somewhere permanently. Just save them in memory, but this gets annoying if the user comes back. We don't have these tokens, so it has to log in again, and we don't want this because this is a very bad user experience. So what we do is, the login flow remains the same. We send our credentials, and we get back our 3 tokens. We also get back a cookie. So we're back to cookies. And we save that session cookie like we did in the beginning, permanently somewhere in our local storage in a cookie. It's a cookie, so it's just a cookie. And we save our tokens in memory. And every time that we visit the website from that moment onwards, we will send this cookie back in the background to our authorization server, and it will pass along the tokens again. So this is a silent request with this cookie. It happens in the background of your single-page application. You do this as soon as it bootstraps, and then after, hopefully, a very short time, you get all your tokens, and you can start using them to do some API requests. And then you use your access token, for example, to access some API. This was the OAuth implicit flow. But recently, the IETF, the Internet Engineering Task Force, published a new best practices document stating that you should avoid the implicit flow. So there's a few issues with implicit flow, like tokens being able, they can be stolen and some other things. And this has been known for years and years and years, or at least a long time. I don't know if it's years and years, but a long time. So now they finally made a document stating that you should try to avoid this flow. And use the authorization code with proof key for concept or for code exchange, PKCE flow. Instead, this does not mean that if you use the implicit flow at this moment, you should all change your code, because I think if you're using the implicit flow, you've tried to think about all the vulnerabilities that come with this flow, and if not, you don't seem to have any problems either. But if you start from new, maybe consider using the PKCA flow instead of the implicit flow. Looks a bit like this. Instead of sending our credentials to the server, we send our credentials plus a code challenge. Then the authorization server sends back, wrong error again, a code, and then we send that code together with the code verifier back to your authorization server. And by sending this code and the code verifier, which is basically just a signature of this code, to the authorization server, we can be sure that this code, that the person who's logging in is actually, it's happening from our app and not some other app which is trying to impersonate us. That's shortly being said. You get back your tokens, same story from here on out. So the thing to remember is the implicit flow is still okay, but if you're building a new app, try to look into the PKCA flow, because that's the recommended way of doing this these days. So does this approach solve CORS? Does this solve cross-origin resource sharing? Who thinks it does? One person. You're correct, sir. Because you can pass along tokens from server to server to server. Doesn't matter which origin they have, because the token has everything inside of it. It has the payload, it has a signature. As long as these servers or services have your secret or your public key, they can verify these tokens. So you're not stuck with cookies which are not really working with cross-origins. Tokens are. Does this approach solve flow? Who thinks it does? Few people. You're correct, few people, because you can just pass along tokens from one server to the other, as long as you know the secret, so you can verify the tokens. Does this approach solve keeping state? Who thinks it does? You're kind of correct, few people. In theory, it does, because the JSON Web Token has everything you want to know inside of it. It's an expiration date, it has a signature. But like we said, we don't want to store these tokens in the front end anymore, so now we're using a cookie anyway, so that's like a little bit in between. In theory, it does solve keeping state, but to do it securely, we still have to use a session cookie, so you still have to use state. So everybody was correct in this one. Then, the future of authentication, something I'm very excited about, is the Web Authentication API, or Web Authn for short. Who's ever used this, played with this, heard of this? Nobody. All right, I can teach something. Cool. So this means no more passwords, because who has the same password for every website? Who knows that this is not a good thing to do? Everybody knows. But we're lazy and we don't want to use a password manager, maybe. I mean, you should, but if you don't do this, you probably have one password. And passwords are a very weak link in our authentication flow. So this authentication API might, in the future, be useful to not have passwords and to authenticate in another way. We've had password login for a while now. Like if you want to log into Slack, you get a magic link, for example, but it still has some password or something saved on the server, so that's not real passwordless. The thing is, you can log in with an authenticator device. An authenticator device is something that might look like this, a little USB drive. Who has something like this? Well, quite a few people. Good. Do you like using it? Who likes using this? OK. I think it's annoying that you have to have it on you all the time, but it does prove to be very useful. So I just plugged it into my computer. And how it works, basically, the Web Authentication API, very simply put, is you want to go to a protected website resource. You give your username. At this moment in the future, you might be able to store user credentials on these devices. So your authorization server sends a challenge to the browser, which the browser will then relay to that authenticator device, this little USB drive. And this USB drive is going to create a public key and private key, and then sign this challenge. And then we send back the public key and the signed challenge back to the authorization server. And then with this public key in the future, it can validate every challenge that has been signed by this authenticator device. So if you would want to log in with something like this, I got something from Chrome which tells me to touch my thing. Then I get a pop-up because I'm on localhost. And once I've touched my authenticator device, I get back a public key. This is a raw ID of my public key. You're not anything with this, so you can just look at it. But I just logged in or just created credentials with just touching this, this device, which I think is very cool because there's no password involved anymore. So I already asked who of you has an authenticator device, but who has an iPhone with Face ID or Touch ID, or an Android phone with Touch ID, or something like this, or a MacBook Pro with Touch ID? Most of you people. So most of you people have an authenticator device. Even if your phone or your laptop doesn't have Touch ID or whatever, they still have a built-in authenticator device that you can unlock with a password in that case. So all of you have this. So if you're using Chrome, you can also just log in with your fingerprint. I just touched my Touch ID, and I get my credentials back again. So we might be able to log into websites in the future with just your fingerprint or something like this. You can use the internal authenticator devices of your laptop or mobile phone, which I think is really cool. It does pose some problems because if I register this one inside of my laptop and then I go to my phone, it has this different authenticator device, so it doesn't know anything about the credentials on this phone. There's still some kinks in the cable we need to figure out. But by using the Web Authentication API, we can try to authenticate without the password and just use a public and private key pair, which is obviously more secure. It's not completely implemented in all browsers yet, like saving user credentials on this authenticated device is not possible at the moment. Touch ID is only possible on Chrome, on macOS, and on Android. But most browsers are working on it. We also have another website called webauthn.me, which kind of demonstrates how it works, this API. So for now, I'll just give a username, doesn't matter, Sam, and the browser is going to go to your authentication server, ask for a challenge. We send a challenge to the authenticator device. I can choose, in this instance, which one I want to use. So I use my fingerprint. I sign the challenge, and I send it back to the browser, which then relays this information back to our authorization server. And we have registered our authenticator device. You can see my raw ID, the content inside of it, my public key. So the next time we want to authenticate, we just send along this raw ID, and we get a challenge from the server. The browser is going to relay this back to the browser, authenticate with my Touch ID, because that's what I chose previously, send it back. The server is going to verify that this is signed by the same public key that we used previously to register. And if it's all OK, we are authenticated in the browser. So that's a little overview on how this API works. If you're interested in this, you can find some more information as well on how it works. at webauthn.me. So let's summarize. Using session cookies is hard with single-page applications because of course, flow, state, and all of these things. They work perfectly fine if you have server-generated pages, there's nothing wrong with those. Just everybody likes this flashy single-page applications these days. So if you want to make a single-page application, it's kind of hard to use session cookies. Status authentication is possible with JSON Web Tokens, but to make it really, really secure, you kind of still need a session cookie or some other mechanism. If you want to, for example, revoke JSON Web Tokens, since they have their expiration date and everything inside of this, they keep on being valid, so you have to create a blacklist, which then again also requires you to make some state, aka the blacklist. So in theory, you can make a status authentication. In practice, there's still some details which need to be ironed out, but it works quite well. JSON Web Tokens consists out of 3 parts: the header, the payload, and a signature, which then proves that it's a valid JSON Web Token. And in the future, we can use web authentication, aka a little USB drive or your fingerprint or whatever, to authenticate on the internet. There's a few resources: JSONWebTokens.io, webauthn.me, a little blog explaining what's going on with the implicit flow with OAuth, and then our blog as well, which has a ton of information about authentication. You can find this presentation here. I'll share it later on Twitter as well. Questions? Nobody has a question. OK, don't know if that's good or bad. Should you have a question, come to me later on or contact me on Twitter or whatever you want. Thank you.